Hi folks, in today's video we are going to be continuing on with the atomic structure. We're going to be looking at ions, isotopes and relative atomic mass. First we're going to be looking at ions. An ion is something that an element wants to do. If you have a look, so an element wants to have a filled outer shell of electrons, and they do this by either gaining or losing electrons. That's what we call a filled shell, so a stable shell. If you have a look at the data book, page 6, you'll see that if you have a look at your noble gases, helium, for example, is number 2, neon is 2, 8, argon is 2, 8, 8. So that 8 or that 2 is a filled shell. That's why noble gases don't react with anything, because they have that filled electron shell. And most elements want to do that as well, so they'll do that by either gaining or losing electrons. For example, if we take sodium, sodium has the electron arrangement of 2, 8, 1, and that last electron, that number 1, wants to disappear. Now it can either do two things: it can get rid of it, or it can add on 7 electrons to make that number 8. Now if you have a think about that, I mean, you're either losing 1 or you're gaining 7, so losing 1's probably going to be the easiest thing to do. So sodium becomes Na plus, becomes 2, 8. Now why does it become a plus? Because it's lost an electron, so it's lost a negative charge, so therefore you're going to have more protons, it's going to be a positive charge. If we have a look at the other side, let's go to fluorine. Fluorine's electron arrangement is 2, 8. Now that last number, 2, 7, it wants to be 2, 8. How does it do that? Well, it either loses 7 electrons or gains 1. It's probably going to be easier for it to gain 1. So that means it becomes an F minus, because it's gained an electron, it's gained an extra negative charge. Now as a general rule, all metals lose electrons to form positive ions, and then non-metals gain electrons to form negative ions. Again, on the data book you've got that little zigzag line to help you identify where the metals and the non-metals are. So let's try some examples. So sodium, I've already told you from the last one, is 2, 8. The electron arrangement it would be, so it would be an Na plus ion. If we go to chlorine, you'll see that it is 2, 8, 7. And it wants to become 2, 8, so it's gaining an electron, so it'll be F minus. Aluminium, 2, 8, 3. Now it's going to get rid of 3 electrons here, so it'll be Al 3 plus, because it's got rid of 3 electrons. And then oxygen is 2, 6. So again, that'll want to add on 2, so you'll put O2 minus up the top. So everything that you've done in the previous video, we can all write in something called the nucleide notation. And that is just basically a shorthand version of writing down where the mass number is, where the atomic number is. So the mass number is always at the top, and the atomic number is always at the bottom, just as I've got in this example. Now say for example we had an ion, the charge would go at the top, so like this for example, or 2 minus, depending on what it is, that's where it would be. So at the top you would have the charge up here as well. So here's an example. Let's start off with bromine at the side. So our atomic number is going to be 35 because it's at the bottom. Our mass number is going to be 81 because it's at the top. Now we know the atomic number is the same as the number of protons and the number of electrons, so we can fill that in. We also know that the number of neutrons is neutrons plus protons is your mass number, so you can take that 81 away from 35 to get the number of neutrons, which gives you 46. Now one of the last new terms that we're going to learn is something called an isotope. An isotope is an atom with the same atomic number but different mass numbers. For example, atoms of the same element but they have different number of neutrons. Most elements exist as a mixture of isotopes. For example, there are 3 main isotopes of hydrogen. So here we have the 3 isotopes. So the first one we've got protium, which has a mass number of 1 and an atomic number of 1. Then we have deuterium, which has an atomic number of 1 still, but a mass number of 2. And then last but not least, we have tritium, which has an atomic number of 1 and a mass number of 3. So if you have a look at the diagram, the first one you can see we've got no neutrons. The second one we've got 1 neutron, and then in the third one we've got 3. That is how we have different isotopes, because we've got a different number of neutrons in the side. We still have 1 proton, 1 electron, that's not going to change, but it's just the neutrons that are different in the inside. So if I asked you to calculate the mass number of hydrogen, sometimes it becomes quite difficult which one I mean, because we have 3 different isotopes. Now to make that a little bit easier for us, we do what's called the relative atomic mass. The relative atomic mass is the average mass of all the isotopes taken into account the proportion of each. For example, if we have a look down below, we've got hydrogen with the different percentages of each isotope. So the relative atomic mass of hydrogen is 1.00794, so we just round that to 1. Now you don't need to worry about memorising this, it's in the data book. So on page 7 you can see that we have this beautiful table and we've got the relative atomic mass highlighted. So for example, aluminium is 27, neon is 20, so that's where it is in the data book, so you just need to be able to remember the page number to find them. I'm going to end this video with a little question. So magnesium has 2 isotopes, 24 and 26, but the relative atomic mass for magnesium is 24.5. Which isotope is more common and why? So the isotope with the 24 would be more common, and why is that? Because the relative atomic mass is closer to the Mg24 than it is to the 26 isotope. If, for example, the average was 25, then you'd say that there was a 50-50 split of each of them, but because it shifted more towards 24, then you would say that the 24 magnesium is more common. And that's just finished atomic structure. Feel free to try some questions just to help you understand some of the key concepts, and if you've got any issues, feel free to let me know.